introduce Dr. Satyasai Nanda. Uh, Dr. Nanda is an associate professor in the Department of Electronics and Communication Engineering, again from MNIT Jaipur. He received the PhD degree from School of Electrical Sciences, IIT Bhubaneswar, in 2013, and MTech degree from the Department of Electronics and Communication Engineering, NIT Rourkela, in 2009. He received the BE degree in Electronics and Communication Engineering from Institute of Technical Education and Research, Bhubaneswar, 2006. He was recipient of Canadian Research Fellowship, GSEP, from Department of Foreign Affairs and Intern Trade Government of Canada for the year 2009-10. He was awarded Best PhD Thesis Award at SOC Pre-ROS 2015 by IIT Roorkee. He received the prestigious IEI Young Engineer Award by the Institution of Engineers, Government of India, in the field of electronics and telecommunication engineering for the year 2018-19. Dr. Nanda participated as a young scientist in a second SCO Nation Young Scientist Conclave 2013 at Jawaharlal Nehru Center of Advanced Scientific Research, Bengaluru. He is a senior member of IEEE and IEEE Computational Intelligence Society, long-term member of Soft Computing Research Society, New Delhi. Till date, he has published about 61 SCI Scopus journal articles, 70 international conference proceedings, one book chapter, and edited 16 book proceedings of Springer, which till date received 2350 plus citation. He received the Best Research Paper Award at IEEE Odicon 2022 at SOA University, Bhubaneswar, and many more conferences as is just a minute. Yeah, he is the in charge of Digital Signal and Image Processing Lab at MNIT Jaipur. He is a lead guest editor of Scopus Index Journal, SN Computer Science, Springer. He is a principal investigator of 5G laboratories to be established by the Department of Telecom, Government of India at MNIT Jaipur. Under his supervision at MNIT Jaipur, 9 researchers have been awarded PhD and 4 researchers are continuing their work. Along with it, he has supervised 32 MTech and 15 BTech projects too. Sir is a co-coordinator of Electronics and ICT Academy at MNIT Jaipur, which is set up to Ministry of Electronics and IT Government of India of grant 10 crore. Dr. Nanda research interests are adaptive signal processing, seismic signal processing, multi-objective optimization, data clustering, neural networks, and evolutionary computation. So, with this vast experience and sir will be delivering his talk. So I believe that participant will be greatly benefited from his talk. So I request Nanda sir to start his presentation. Thank you, sir.
Thank you, Chirag sir, for reading a long biography
Long.
for such time. Thank you for the elaborative introduction to the
Because
participants.
you have elaborated research.
So let me share my presentation and I hope
Yes, sir, it is
Yes,
visible.
yes,
visible.
visible.
Yeah, and when I am writing on my pen, I believe it is working, right?
Yes,
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 yes.
it's working.
Okay. So just a minute. Yeah, so before starting the presentation, I just want to highlight something that if by chance I get disconnected, you have to give me a call. Okay.
Yes,
Okay.
yes.
Because as it is an online talk, otherwise I will be keep on talking while the thing will be by chance if get disconnected. Okay. So my
Okay.
mobile
Yes,
my
sir.
mobile number is there with you, Chirag sir.
Yes, sir. I am having it.
Okay. So please take care, and can I able to switch off my camera
Yes, yes, sir.
to save just bandwidth for all the people?
Sure, sure, sir.
Okay. Hmm. So today we are going to discuss about the artificial intelligence application to image processing. And all of us know that today the image processing has become a very important field. Okay. Sir, my talk is audible, right?
Yes,
Things are
yes.
running fine. Okay.
Yes, yes. Whatever, whatever.
Okay. Okay. So image processing is very, very important. And compared to the regular image processing, the important parts comes when the image size becomes very, very big, the size of the image becomes very large, and they are very difficult to process. So under those circumstances, how we can effectively apply the artificial intelligence based algorithm, that becomes very, very important. Okay, I am talking about very large size image, and one of such type of image is hyperspectral imaging. Okay, if you can observe, this particular type of images are normally captured by satellites. Okay, how satellites capture image? Satellites send some amount of signal to the earth surface, and these signals from the earth surface, they get reflect back. Once they reflect back, the satellites again collect those wavelengths, and those wavelengths gets converted into image. The type of wavelength it says, long wavelengths, they are perceived as red color. Medium color wavelengths, they are perceived as green color. And short wavelengths, they are perceived as blue colors. So in this particular picture, you can able to observe that there is a river over here. I am highlighting with my red pen. You can observe that here there is a river which is flowing, and that has submerged to the sea over here. This below part, dark color, this particular one is the sea, and the river is submerged to the sea. And on both sides of the river, there are terrain regions and there are some greenery regions. You can observe here there are some forest areas, greenery region. Here there are some terrain regions are there on both sides of the river. And such type of one particular image has been captured. Okay. To capture this particular image, we use different type of wavelengths that have been transmitted from the satellite, okay, on the spatial area. And on one particular wavelength, we obtain one particular image. And as we are transmitting several bands of wavelengths, so we will obtain several such type of images. And that image, that makes out a image cube. You can observe on this, this is not a two-dimensional thing, but it is a three-dimensional thing. Okay. Normally, every image is represented by its pixel values. So on this X and Y, there is pixel value, and on this Z axis, you are observing there is a cube type of thing. So on this Z axis, there is lambda. Lambda is that particular wavelength on which we are transmitting or receiving the particular image. Okay. So this particular entire volume of image we receive at the satellite, and we have to process this particular image very effectively so that we can capture very important information out of it. Like these days cyclone prediction that happens some 7 days, 5 days, 7 days before, so that the precision becomes very very accurate and we can dislocate the peoples who are near the seashore to a safest zone so that minimum amount of life can get into danger, or we can save a lot of people's life especially. So as I have told that these images are captured with hyperspectral sensor. Okay, these hyperspectral sensor, they transmit these particular wavelengths and then collect the particular information. So the image are combined in the form of a three-dimensional thing, x, y and lambda. Xy represents the two spectral dimensions and lambda represents the spatial dimension comprising of a range of wavelengths. And one of the most popular example is NASA's airborne visible infrared imaging spectrometer. AVIRIS is one of the popular spectrometer with which a lot of such real life images can be captured. And when these type of images are captured, then there are two type of things. Either it can be a continuous band of images or the images can be discrete in nature. Means not at every wavelength we are capturing the image, but with a gap of certain wavelength if we are capturing, then that particular one is known as a multi-band imaging. And if it is continuous in nature, then we call it as hyperspectral imaging. So you can observe hyperspectral imaging is continuous and it takes care from 400 to 1100 nanometer with a step size of 1 nanometer. That means in every 1 nanometer, one image gets captured. But in multi-band imaging, again from 400 to 1100 nanometer, but with a step of 20 nanometer gap, we are collecting the image. Okay. So hyperspectral image is more bulkier than multi-band imaging. In this 1.5 hours, I want to highlight two important problems of these type of images. One is segmentation of these particular images or breaking down these particular images into different segments so that we can analyze each individual segments and extract very meaningful partitions or information out of this entire image. Okay. Second thing is, as these images are collected in the form of a huge number of bands, like 100, 200 number of bands are there. So the entire image size becomes huge, like 15 GB, 20 GB. So such a huge volume of image is difficult to process. So can we select few bands out of these 100 to 200 bands? Like out of 200 bands, if we select 20 bands, which 20 retain the most important information and reduce the size of the image from 20 GB to, suppose you can say, 2 GB or half GB. Then half GB or 2 GB is easy to process and extract important information rather than processing the entire 20 GB. So band selection is another very important problem. So these two problems I want to discuss over here. I hope everything is going fine.
Yes, sir.
Okay. So let's talk about the aspect of the first problem, that is the image segmentation of these hyperspectral images. Okay. So few important application of such type of imaging are fire detection. If we can able to detect the fire inside the forest as shown in this example A, then we can save a lot of animals and other creatures life, as well as important medicinal plants which uh, uh, which will be beneficial for humanity. Okay, once the fire spreads inside the forest, then you cannot able to stop. Okay, so timely if you will get the information, you can alert the authority and they can able to spray some water or something with the helicopter, and you can control the fire also on the forest. Another important application is glacier detection. Why glacier detection is a very important problem? Because many times because of the glacier sliding, the human beings they are living just below the glacier, they get trapped. Like the humans, they are the Eskimos especially, they build their igloo below the glacier. So once there is a slide, then their entire things get swept away inside the ice. So it is very important that we should detect the glacier a priori, glacier sliding, and inform the people. The third important thing is water detection. If there is some water bodies is there on the top of a terrain, okay, you are observing there is a huge mountains are there. On the top of the mountain there are some portions in which the water bodies are there. So if we will have a information about those places, then the things can be helpful for humanity when the peoples are doing hill climbing as well as remote area studies. This is very important that we should detect the water on the remote areas. Another important application is landscape monitoring. So normally the coastal areas, there are certain places which are very sensitive, and due to tsunami and large waves, these areas get submerged. So you can alert people timely so that there will be little impact of this tsunami or earthquake inside the ocean on the coastal area. Apparently you can able to inform. If you can detect and analyze these particular satellite images perfectly. So there are many type of image segmentation methods have been reported, especially the graph cart models, binary image segmentation, multi-level image segmentation, region-based segmentation, age-based segmentation. Recently, the neural networks, there are many such type of techniques, both supervised and unsupervised machine learning, deep learning. uh, All these techniques have been already used to effectively partition these images. So you can observe on the left side, there is a satellite image which has been bifurcated into four different parts. So this is the segmented image which comprise of these B, C, D, E, four different part. You can able to observe that this C part contains only water. This D part contains only vegetation. E part contains only terrain region. So, and the B part contains only the cloud regions. Okay. So, in one image you got cloud, in another image you got water, another image you got vegetation, and another image you got hilly area information. So analyzing each individual segment, you can suppose there is a water rise in particular portion. The sea banks, the river banks have risen because of certain heavy rainfall. So then you can able to give a message to the people who are staying near to this coastal belt of this particular river that the river banks are increasing and you people get alert. Timely giving alert is very important thing over here. So when we are doing this type of segmentation, okay, one very important aspect is the segmentation can be viewed as a cluster analysis problem or a grouping problem. You can observe that blue color points, entities, they are grouped together. Green color entity, they are grouped together. These terrain regions, some different color pixel values, they got combined together to form another type of group. So this grouping type of thing can be formulated or visualized as a clustering problem. So mathematically telling you that if we are saying it as a the image as a n cross d dimensional thing, you can observe that this P11 to P1D is one line of the image and this entire image comprises of Pn cross D. Then our objective is to segregate this particular image into m number of groups or clusters in such a way that every group must have at least one pattern. Means you can able to say one particular segment exists if there is at least one pixel value in it. If there is no pixel values is there, then that one cannot become a segment. That is, none of the clusters should be phi. This is one basic assumption. The second important thing is there should not be any common patterns between any two clusters. Means if I am saying that one particular cluster belongs to water and another particular cluster belongs to vegetation. Okay, that means one particular one color is blue, other one color is green. You cannot able to say that one particular pixel that belongs to both vegetation type as well as water type. So the common thing between water and vegetation that does not exist. Okay, one particular pixel has to either becomes a either it has to becomes vegetation or it has to become water bodies. So the intersection between two different clusters Ci and Cj is equal to phi. Okay, so between two different entities there is no common element. Okay. The third important thing is if we have divided an image into a number of clusters, okay, then the summation of all the part is equal to that particular image. So this is the summation of all the clusters is equal to the entire image. That means over here, this particular image A has been partitioned into four different parts B, C, D, and E. So B plus C plus D plus E is equal to this A image. Okay. I hope it is clear to everyone. Am I connected?
Yes, sir.
Yes, yes.
Shall I move ahead? Okay.
Yes, yes.
If things are running fine, I will move ahead. Yeah.
Yes, yes.
So when these AI based techniques were not so popular, earlier people used to use these particular statistical techniques for the image segmentation. For last 50, 60 years, people were doing image segmentation, you know. And k-means based algorithm for image segmentation have been very popular for last 50-60 years. 1960 this particular algorithm got invented, and after almost 70 years of its existence, more than 70 years of its existence, still people are using k-means algorithm. Okay, why? Because its computational complexity is very low, and you can easily apply this particular algorithm to cluster big data set. Big data sets, huge number of samples and huge number of dimension. If you wish to group, find out groups in that, okay, then k-means is one of the basic as well as very popular technique for grouping. Okay. So big data, when you apply, you can apply also to big size images as well. So in hyperspectral imaging also people use the k-means based algorithm. So over here certain number of points, if you will observe, here there are ideally a lot of points are there on this. Okay, there is initially no partition is there. We have tried to find out two partition of this particular points. So we have highlighted two centers. One is this red color point and another one is this yellow color point. These 2 points we have taken initially, okay, as centers, and from all these points we have tried to find out what is the minimum distance with respect to these cluster centers. Okay, so distance we can able to find out Euclidean distance. So minimum Euclidean distance from these cluster centers we try to find out, and then try to group them into two different parts. You can observe, as I have highlighted, from these points this red color triangle is closed, and from these points this yellow color triangle is closed. So thereby, if we have taken into account these particular points, all are friends of this red triangle, and these all points they are friends of this yellow color triangle. Okay, thereby this has been bifurcated into two different parts. Okay, and then these triangles we have initially taken them random position, then we have tried to shift their things, shift their location to a central location. That's why it is known as mean algorithm. K means, okay, k stands for how many number of partitions, k is for 2 over here, how many part you want to divide, or how many cluster or how many segments you want to divide, and mean stands for these moving of these centers into the approximate middle region. Okay, so this is how in the entire cluster the center lies in this particular middle location. Okay, so like this the algorithm moves, and finally you observe that you have found it out two round shaped clusters over here, almost circular shape, two clusters. So you can use different type of distance, like Manhattan distance is very popular, as well as Euclidean distance is also very popular. So these two distance can easily be used for this type of segmentation. So the drawback of this statistical k-means based algorithm is that it always try to formulate spherical or circular type of clusters, and many times in real life the clusters are not spherical or circular type, but they are of arbitrary in nature, or arbitrary shape clusters are there. Okay, so for this is an example, like the Eastern Arizona dataset, fire dataset, that has been clustered into 4 clusters. You can able to observe with k-means based clustering. This is the fire uh, inside a forest area, in which the smoke region has been found it out in one, terrain region in another one, a greenery region in one, and another one is this particular one. So 4 different clusters. Like Abstral Island image taken again with NASA has been clustered into 2 different parts. One is the island part and another one is this ocean part. So 2 different part it has been bifurcated into. So considering this particular thing and limitation of k means just to formulate circular shape clusters, we have taken the help of AI based techniques. Okay, there are many AI based techniques and AI based techniques deal this clustering as an intelligent optimization problem. So over here we need to optimize the clusters by considering a function which relate the data set and the cluster center. Okay. Like one of the thing is minimization of Euclidean distance is one aspect. Similarly, many other functions can also be taken. Okay. And for such kind of thing, we unsupervised learning, now we are taking the help of nature inspired optimization techniques. Okay. So nature inspired optimization techniques, they have been reported in last 2 decades, more than 2 decades, with the beginning of genetic algorithm, all of you know, and they have the capability that they can effectively find out a global maxima solution in the presence of multiple maximas. Multiple maximas means what? Over here in this particular surface you can observe here there is one maxima, here there is another maxima, but this is our global maxima. So if we are employing certain solutions, certain elements to find out this particular global maxima, then here these all elements like element 1, 2, 3, 4, 5, 6, all these 6 elements, they will try to find out this particular global maxima on this particular surface. And these elements can be bars, can be ants, can be molecules, can be any particular type of creature you can able to say. We can say them as intelligent creatures. Okay. One of the very popular researcher known as Marco Dorigo, he observed these particular elements behavior like the ants. Okay, so ants, they always search for the food, and whenever they find the food, they take these foods on their head and they straightly move to their nearest holes. Okay, so the hole to the place of the food, they normally move in a particular line. As you can observe, all ants, they move one after the other. Okay, they take the food in their head and they move on one particular path. Okay, so when they move in that particular path is a optimal path they normally use to draw. Okay, and nobody knows till date, till Marco Dorigo proved that the way the ants are moving, that is a optimized path they have drawn, and with their intelligence, they have made a optimized path. So like that, there are many other algorithms which also inspire us that how to formulate formulate and solve an optimization problem. And over here, data clustering is visualized as a unsupervised optimization problem, unsupervised machine learning problem, you can say, or optimization problem which can effectively solved with various nature inspired optimization techniques. Okay, and all such kind of complex nonlinear problems can also be solved. Multimodal problems can also be solved for such type of things. Like over here, a mathematical functions with 2 variables. Okay, but it has a nonlinear case and it is having more than one minima. You can observe that here there is one minima, and there are many other points also in which minima are existing, and the global minima of this problem is at this particular point, and the global minima solution is -2. So like that, many such kind of problem, multimodal complex problems can effectively solve with nature inspired algorithms. And these are some of such complex benchmark functions. You can observe that all these are nonlinear and complex variables based functions, and the nature inspired algorithms can effectively solve these particular complex problems. Okay. So the nature inspired algorithms, when I say, they belongs to the part of the artificial intelligence, and they are broadly classified into certain categories. One of the first kind of category is known as evolutionary algorithm. Evolutionary algorithm means what? Evolution with respect to the time. They are inspired by Darwin's theory of evolution. Okay. And Darwin's theory of evolution says survival of the fittest. Dinosaurs could not able to survive today. Why? Because with respect to the time, they could not able to adjust themselves. Human being, they try to adapt themselves with respect to the change in environment. So that's narrates it to the survival of the fittest under critical circumstances. And based upon this type of concept, genetic algorithm was first introduced, okay, by John Holland, who is the father of the genetic algorithm, and many people have applied it for clustering, cluster analysis, and such type of problems also do have another aspect, is you are dealing with one particular function for clustering or more than one functions for clustering. If you are using one particular function like minimization of Euclidean distance, then it is a single objective type of problem solving. And when you are trying to deal with many more functions, then it is a multi-objective type of problem dealing. Like I told you that the genetic algorithm from parents to the next generation, they becomes intelligent, they becomes adaptive, they becomes uh, more smart than their parents to the change in environment or and enhance their adaptability. Okay. Similar way, there is another kind of algorithms, they are known as physical algorithms. So these physical algorithms, they are popular algorithms are like memetic algorithm. So a group of creatures, they learn from their environment, and when they migrate to another environment, they again adapt themselves. That is what the behavior of memetic algorithm is. And the third kind of thing I told you, like the ant colony optimization by Marco Dorigo and particle swarm optimization, another very popular algorithm by Eberhard and Kennedy, that comes to swarm intelligence category. Swarm intelligence means collective intelligence of a group of creatures, like a group of ants, a group of birds, a group of fishes, a group of elephants in a herd, like elephant herding. So a group of creatures, their behavior in groups. Okay, a lot of birds, they migrate in winter time from the North Pole towards India and other middle part. Our lakes, they become filled with the birds. Okay, the bird's behavior for flying so long, how that is there, that has been mimicked in the form of mathematical algorithm. And that's bring out one type is particle swarm optimization. Similarly, there are other natural inspired algorithms like bio inspired algorithm. Okay, these are biologically motivated and inspired algorithms like artificial immune system. And after COVID, many people talk about the immunity, immune based algorithms, immune based concepts. They got a lot of boost like the bacterial foraging based algorithms and many more such kind of natural behavior based algorithms have become popular. Okay, so before moving ahead further, uh, I want to ask if there is any query over here till now.
Yes, participants, you can write in the
If you
chat
are,
box.
you can write in chat box. No query?
Hope everyone is following.
If they are following, then that is very, very good.
Yes, yes. It- Emoji. There is a emoji. Oh, yes.
Hmm.
Yeah, that's the way to answer. Yes, sir, you can continue, sir.
Yes.
Sure, I am continuing.
Yes.
So, one of the very popular fundamental technique is particle swarm optimization. Okay. So, this particular concept came out in 1995 initially by Kennedy and Eberhard. Okay. And I am not talking a new thing because it has been invented in 1995. And today I am telling you in 2025. That means almost after 30 years. And all of you on a certain span of time, you must have heard about this particular algorithm because it has been so popular all and around the engineering field. Okay. And it is based upon the concept of swarming. Okay. And this particular paper, IEEE Transaction on Evolutionary Competition, it deals about all such kind of evolutionary concepts and algorithms. This 2002 paper tells about the stability convergence of this particular algorithm in a multidimensional complex space. So now just say about this particular algorithm in a very simplified manner. Suppose we move to a pond and in the pond we throw some amount of food particle. Okay. So when we throw some food particle, do you believe all the fishes in the pond they can able to see the food? No. The fish which is very close to this particular food that can able to observe this particular food. Okay. So once it observe this particular food, what will happen? It will move there and take a estimation of the particular food. How much amount of food I have got. Okay. And then that fellow will inform its friends that bingo, I have got some food and all of you come here and we will have the food together. Okay. So that fellow moved there, then send a signal to its friends and all of them moved there. Okay. And they enjoyed the food. Okay. So by the time they all moved there, okay, then there is another possibility that some other friend also got some food. Then they fellow will again inform to its rest friends and they all again migrated to that particular place. Okay. So by this particular process, they will get the biggest amount of food and they do not have to starve for long. And with this, if we will try to mimic this particular thing in the form of mathematical model, then here is the thing. In the left side, you imagine this particular boundary, this particular circular boundary as the pond, and inside the pond, this particular small brown ball is my food, the food I have thrown. xy1, xi2, these all are particles, and vi1, vi2, they are their velocities. So every fish is represented by a position and a velocity. So xi1, vi1 is the first fish position and its velocity. Why velocity? Because the fish is moving in certain direction. Okay, it has got a position and it has got a velocity. So like that, you can observe that this xi3 fish that is very close to this particular food. Okay, and that's why this particular fellow is known as a global best position. Global best position means that is the best position in the swarm. Means if there are 10 fishes are there, out of the 10 fishes, which particular fish has got the food, or which particular fish is very close to the food, that particular one we call it as a global best position. Or among the entire swarm, which one is the global best, which is the close to the food. Okay, that will lead the entire group towards the food. So after certain time, if you will observe, all of them who were initially randomly roaming here they are, here they are, their positions and velocities get updated, and after certain time you will observe that all these fishes, they all are traveling towards the food. So they all are moving towards the food. Okay, so how this happens? With the help of mathematical equation. So the particle positions and move velocity, they get changes. This is initial position of the particle. This is initial velocity associated with the particle. And this is the global best position associated with the particle. And there is another thing is known as local best position. Considering these four things, the velocity and positions get updated. So over here, this is the update equation for the velocity, and this is the update equation associated with position. Okay, so here if you can able to observe mathematically, this is the update equation of the position is equal to the previous position of the particle with an updated velocity. So the updated velocity get added with this particular position to get the updated position, and the velocity get updated considering the previous value of the velocity. So velocity at k plus 1, that depends upon velocity at k. Okay, and a difference vector over here, the local position minus the present position and the global position minus the present position. This means this is the best particle of the swarm. Okay, best particle means what? Who is close to the food. That fellow is calling all its friend. Come, come, we will have food together. That is the global best minus the present position. And every individual has a way to find the food. And that is what is the local best minus the present position. So these two factors will drag our faces towards the global position. Okay, and always the velocity change with the previous velocity, because when a fish is moving, there is a velocity associated with it, and that moves in a consistent manner, that is known as movement of inertia. Okay, so if something is flying, then there is a tendency to fly in that direction. Some fishes is moving, is swimming in a direction, there is a tendency to swim in that particular direction. And that particular thing is known as movement of inertia. And this weight is known as inertia weight, that is multiplied with this particular previous velocity. So when you apply such kind of algorithm, always restrict the position of the velocity and the position of the restrict the velocity and the position to a maximum limit. Otherwise, these fishes will search their food outside the boundary. That means there is a circle you are observing. If these fishes will search beyond this boundary, then what will happen? Outside the food, outside the pond, they are not going to get the food. They will get the food only inside this particular pond. So there is no meaning to search outside of it. Okay. So always have a limitation on the velocity and always have a limitation on the position. That is what very important when you apply particle swarm optimization algorithm in solving such kind of problem. Okay. So this is the steps associated with this algorithm. Mathematically, I have already explained this algorithm to you. Like I have told you this particular algorithm, particle swarm optimization, you have to initialize the particles, then do the velocity and position update, and calculate the global best and the local best position, then the fitness evaluation, then select it, then repeat this particular process for certain number of generation, because it is a iterative process. It is not a one way of thing, but it is an iterative process, and the final thing is the cluster output you are going to obtain. Okay, so this is the cluster output you will be obtaining, which is the final result. Okay, so to analyze this particular algorithm for different clusters, you have to use certain fitness function. Like in k-means algorithm, we were using Euclidean or Manhattan distance minimization as cost function. So for particle swarm optimization and other intelligent algorithms, you also need certain benchmark fitness evaluation functions and the cluster validity indices, which are very important. So to get the effective clusters, you can observe that certain of distance minimization, like the midpoint distance, centroid distance, Digiton distance, all these distance minimization, they gives effective results. Certain conditions maximization again gives very good results, like Dunes index, David Borden index, CS measure, Silhouette index, all these minimization, maximization, that gives you effective results. Okay. And these are the scientists who have already used such kind of mathematical functions over the years. And this is a survey review article on these particular algorithms for the cluster analysis I have written, and this particular article, single article, has got around 700 citation till date. So people are following this article, and you can also follow this article for more details about these clustering algorithms for effective image analysis. Then there are few more such kind of intelligent algorithms are there, like the particle swarm optimization. There is a social spider optimization, which is again very popular, I can able to say. So in such kind of algorithm, this algorithm is relatively new, I can able to say. In last uh, decade, it become very popular because of its accuracy, I can able to say. It is more accurate compared to PSO, but its computational complexity is bit higher than PSO. Okay. So in this algorithm, like the PSO's particle positions and global velocity, they get updated. In this particular algorithm also spiders positions get updated. But the important thing compared to PSO, this algorithm takes nonlinear movements. PSO, all the particles positions are straightforward movements, straightforward vectors, vector additions. But here it is a nonlinear movement. The movements on the colony are nonlinear. And second important thing is it is a multi-agent algorithm. When you talk about in artificial intelligence, it is something is multi-agent. What do you mean by multi-agent? That means different kind of search agents. They work together to solve a particular problem. Like the male spiders, their movement is one type. Female spiders, their movement is another type. Baby spiders, their movement is another type. Here, three different type of search agents. They together try to solve the particular problem, and such type of thing is known as a social spider algorithm based on multi-agent analysis or multi-agent algorithm, you can able to say. So this is a wave on which there are several spiders you can able to observe, and you fix in your mind that here this particular kind is a female spider, this particular kind is a male spider, and the small ones, they are the baby spiders. Okay. So like this, I told you female spider, baby spider, and dominant male spider. Okay. So 60 to 90% of the spider population comprise of females, as reported in the discovery channels, and various scientists have reported that the female population in the spider is always more than the male counterparts. So 60 to 90% spiders are assigned as females, and rest spiders are assigned as males. Okay. And the algorithm starts with a swarm of spiders. Okay. And then you carry out the fitness evaluation with any of the statistical measure like the Euclidean distance or kind of thing. Then you assign weights to the spider. What is the weights of the spider? A more healthy weight of the spider, it is a more fitter one, we can say. Then the communication among the spider, I told you, the communication happens between the global and the present spider and the local and the present spider, and this particular one happens to be e to the power minus delta, wl into e to the power minus delta. That means over here this is a exponentially decaying factor that has been taken into account. That means the heavyweight spider that punches on the web, you can able to observe on this web there is a heavyweight spider which gives punches on the web, and once the punching is happened, this vibration spreads over the web throughout everyone, and all try to communicate each other with this particular vibration. So considering this vibration into account, these communication weights update movements have been defined like this, that the spider movements is followed this particular equation if the random number is lower than a probabilistic factor, and this takes this particular equation otherwise. So like this the spider movements happens for females like this, and this is helpful for the exploration of the algorithm. Exploration means searching the entire space in and around the algorithm. So that is how the spider movement happens. And then the dominant male spider movements that happens with this particular weight update equation, and the spider movement happens over here. Then the non-dominant male spider movements happens with this particular equation, which is responsible for exploitation of the algorithm. Exploitation is responsible for deep search in and around a nearest solution to find the optimal solution. So along with this search mechanism, there is mating happens between the spiders, and for such type of mating, there are three female spiders as I told you, and one male spider, because female spider population is high, and among these whose probability is higher, like this one's probability is higher. So the baby spider takes the position of the mother. So the 1 and 0.5, this has been copied over here. Okay. So the best solutions, they propagate from one generation to another generation, and like that the movement takes place. Initially in the original algorithm, there is this female spider update, dominant male spider update, and non-dominant male spider update. All these updates happens one after the other sequentially. But we have developed a parallel algorithm with paraform looping and all, in which these all things we have made it in parallel run, parallel execution, and thereby saving the computational complexity to a much lower amount by processing these things in parallel core. And we have applied these on high dimensional data set and images, okay, and shown effective results on them, like 1000 number of iterations and 10 independent runs, the errors have been very low, and the computational time is drastically reduced compared to the original algorithm, like from 44 to 25, 35 to 25, and like that. Whereas maintaining the classification error percentage almost similar, okay, slightly improved in this parallel version of the social spider algorithm. And here it is applied for the images on the flood affected area of Chennai. This is the sea coast, okay, and near the sea, this is the region, and there is a lake over here, and you can observe that from this particular satellite image, this is the water retention before the flood, okay, and here there is a river which is very close to this particular lake, and this is the seabed, okay, and after the flood you can observe this river bank has increased, this particular locations water retention has increased, and near to the seashore there is a lot of water activities that has been spotted over here. And analyzing such kind of thing, if you can able to give people warning before they think, then it will be very very helpful for them. So I told you about the first problem, and this is the second problem, that from the hyperspectral images you have to select few bands. Like here there is huge number of bands in a Pavia University image, and from these huge number of bands we have selected few number of bands with a band selection technique, and then effectively apply the clustering algorithms, and then the cluster image we have obtained, which is very very effective. So for analyzing such type of band selection technique, we can able to take various kind of statistical measures along with the intelligent algorithms, like first particular objective taken as a maximization of variance of fast spectral derivative that can be taken with the distance matrix, as you can able to observe that from 1 to lambda there are many bands have been selected with various among the things. We are trying to take the bands which are especially giving us disjoint information. Okay, so there is minimum values which can able to show the maximum similar information. We try to reject such kind of band which have similar information. Which information is dissimilar, we can able to take those bands. Another thing is entropy. We can able to minimize the entropy. Okay, and entropy, as you know, it is the information content in the image, and it can minimize the uncertainty in the bands in the image. Then maximize the coefficient of variation is another important parameter. And like that, many objectives you can able to take and simultaneously analyze the thing. And when we say that more than 2 3 objectives, then you should always apply the multi-objective based algorithms which have been reported by many researchers, but most important is Professor Kalyanmay Dev. He is presently at Michigan State University, USA. Formerly, he was the director of Kanpur Genetic Algorithms Laboratory, IIT Kanpur earlier. This is his Michigan State University website. This is his IIT Kharagpur website. And you can always refer his paper on this an evolutionary many objective optimization algorithm using reference point based non-dominated sorting approach. This is the NSGA3 algorithm. NSGA2 algorithm was very popular, which came around 2002, and this NSGA3 came in 2013. As you can able to observe, a very popular algorithm in IEEE transactional evolutionary competition. So we have worked on this particular algorithms, and we have also published on IEEE Congress on evolutionary competition binary version of these algorithms for this band selection in hyperspectral image analysis. And this particular algorithm, binary NSGA3, is having lower computational complexity compared to the original algorithm. So in this binary NSGA3 algorithm, the original for band selection, it has been viewed as a selection problem, and here 1 represents whether a particular band is selected and 0 represents a band is rejected. So we have to select fewer bands than the lambda bands. And the procedure of NSGA3 follows, and you can refer more on this particular research paper. And here there are logical crossover, logical mutation operation we have introduced in the binary genetic algorithm, which are very popular. And this is the procedure of the binary NSGA3, which you can refer on this paper. And you can observe that while applying on these particular images, a lot of comparisons have been taken. And here there are 100 number of bands, out of which only very few bands have been taken. White color represents the bands which have selected, and dark color represents the other bands have been rejected. So compared to many other algorithms, this algorithm is performing very good over here. And considering this, then further cluster analysis have revealed the effective solution for this particular problem. The Pavia University hyperspectral images have been effectively analyzed, and the results have been compared with the ground truth one. This is the ground truth one. The obtained results have been compared. And cloud movement detection, we have taken, like the movement of clouds have been detected effectively, which is very, very helpful for the cyclone prediction with this particular algorithm. So I have told you about various benchmark techniques and recent AI-based intelligent unsupervised techniques which can be effectively applied for the image processing, especially hyperspectral and multispectral image processing. And you can refer various research papers related to it on my MNIT website, Bidwan website, Google Scholar, and Orchid profile, and problems also. So you can refer all these things, and whichever things you are interested, you can work on it. If you will have doubts, then you can ask me on this. These are some of the benchmark journals: IET, IEEE, Elsevier, Springer, and these are some of the benchmark conferences we have cracked. So that much from the presentation from my side for today. Your queries, I will be happy to answer.
Yes, participants, if you have any questions, please. Sir, there are some questions on the chat box, if you can access.
Yeah.
For combinatorial
Combinational
non-linear convex optimization, which optimization technique give best result?
For combinational thing, also you can use the genetic algorithm, especially NSGA based algorithm, non-dominated sorted genetic algorithms. They gives best result if you consider accuracy. Also, the particle swarm optimization also can be used. Both the algorithms are very, very good.
Okay, one more question is there, just before, yeah. For defense system like drone anti-missile technology, this hyperspectral is used.
No,
Sir, what is the question? Yeah.
the thing is that for drone and anti-drone missile technology, this hyperspectral cannot be used because these for them actually lightweight technologies are used. These are satellite captured images for long prediction, huge volume, 25 GB image. If you will if you will use for
Yeah, it is
drone
not feasible.
technology, by processing it will take more time. So you
Yes, it
cannot
is
able
not
to
feasible.
do. So it is
Right.
not feasible. So for this defense system, this kind of imaging is not used. This is for long weather prediction and such kind of thing it is used.
Okay, any other question?
Is there any method to select algorithms? Yeah, some of the algorithms are actually heavy and some of the algorithms are lightweight. Like particle swarm optimization, it has two equations, two mathematical equations only, as I have already explained. So its computational complexity is very low. So that's why people use it for all those applications which are online in nature. That means quickly you will get the solution, may not be very accurate. Okay, and some other algorithms are heavy algorithms like the non-dominated sorted genetic algorithms and all. Their computational complexity is very high, but simultaneously they give you very, very accurate results. So for online application, PSO based algorithms are better. For offline application, the genetic based algorithm approaches are better. So that is what my point of view to segregate the algorithms. Online application go for less computational complex algorithm. Offline application go for heavy computational complex algorithm.
Is anyone
Any other
else?
question?
Okay, as I don't think there are no more questions. So I am
Yes,
keeping
sir.
my
Contact.
if there is any further question, they can write it to me on this email ID. Okay, I have written
Okay.
there in the chat box.
Yes.
So that much from my side. I have answered the queries. Thank you, the organizers.
Thank you.
Anything from you?
Thank you
Thank
very
you,
much,
sir.
sir. It was a
Thank you.
very interesting session.